Problem number 5. A 2.5 kilogram block is initially at rest on a horizontal surface. A horizontal force F vector of magnitude 6 Newton and a vertical force P vector are then applied to the block as shown in the figure. The coefficients of friction for the block and the surface are mu s equal to 0.40 and mu k which is equal to 0.25. Determine the magnitude of the frictional force acting on the block if the magnitude of P vector is A 8 Newton, B 10 Newton and C 12 Newton. In this question, we are going to find the magnitude of the frictional force for the different values of the vertical force P. Here, the mass of the block is given as 2.5 kilogram and that block is kept on the horizontal surface. So in this block, we applied two forces. One is horizontal force F vector and the another force is a vertical force P vector. So in this question, we have to find the magnitude of the frictional force. For that, first of all, we have to find the maximum static frictional value. If the maximum static frictional value is greater than the applied force, that is our horizontal force, then the object will not move. Suppose if the applied force will be greater than the maximum static frictional force, then the object will start to move. By that, the static friction is converted to kinetic friction. So in this question, we are going to find the answer for different values of the vertical force, which is A equal to 8 Newton and B equal to 10 Newton and then C 12 Newton. Clear? Okay. First of all, let's write the given. So the mass M which is equal to 2.5 kilogram and the magnitude of the horizontal force is 6 Newton and the static coefficient value is 0.40 and the kinetic coefficient value is 0.25. So now what I have to do, I have to draw the free body diagram for this figure. So this is the vertical force they already gave and this is the horizontal force they already provided, right? So now we have to draw the normal force. So generally the normal force will be acting perpendicular to the object surface. So that means this is the normal force which is Fn. And then the downward force is force due to gravity which is mg. Clear? Now we have to frame the equation from the free body diagram. Correct? Okay. So how many upward force we have here? We have two upward force and one downward force. So two upward force here is Fn plus the vertical force P vector which is equal to mg, right? Now we have to rearrange this equation in terms of a normal force. Therefore, Fn which is equal to mg minus P vector. So actually this P vector we have to consider the magnitude. Clear? So now I have to apply the value of m and g here. So let's substitute the value Fn which is equal to 2.5 kilogram multiplied by 9.8 minus P vector. So when you multiply 2.5 with 9.8, you will get the answer as 245 Newton minus P vector. So now we have to use this equation, and in this equation we have to apply the different values of P vector magnitude. Actually we have to make a magnitude value. So in the question they already gave the value of P vector as 8 Newton, 10 Newton and 12 Newton. So that means for each and every value of the P vector we have to find the value of the friction. Clear? Okay. So first step, what I'm going to do, I'm going to substitute the P vector magnitude which is our vertical force. I'm going to substitute 8 Newton in this equation. If you substitute 8 Newton in this equation, what we will get? Fn which is equal to 245 minus 8 Newton. So here we got the answer for the normal force as 16.5 Newton. Now, by using this normal force, I'm going to find the maximum static frictional value. So, maximum static frictional value, a rule we already studied in chapter number 6, which is mu s, that is as coefficient of the static friction multiplied by the normal force. So, the static friction value of the friction is given as 0.40, and the normal force value here we got as 16.5. So I have to multiply with 16.5, and when you multiply 0.4 with 16.5, I got the answer here as 6.6 Newton. That means a maximum static frictional value I got here as 6.6 Newton. Now you can compare this value with the horizontal force. So you have to go back to the figure. You can see here our horizontal force magnitude is given as 6 Newton, but our maximum static frictional force is 6.6. So here our magnitude of the horizontal force is 6 Newton, but our maximum static frictional force is 6.6. So which one is greater? Our static frictional force is greater. So that means if the value of the maximum static frictional force will be greater than the applied force, which is our horizontal force, the object will not be moved. So what you have to give the answer, the block is not moving. Why? Because our static frictional value is greater than the applied force. So that's the reason the block is not moving. So you can see the maximum static frictional force is 6.6 Newton, but our horizontal force here is 6 Newton. So here maximum static frictional force is greater. That's the reason the block is not moving. Now what we have to do, we have to apply the second value of the vertical force. What is your second force? 10 Newton. So you have to apply, in place of P vector, we have to apply 10 Newton, because the magnitude of the vertical force value is given here as 10 Newton. So now what I have to do, in the main equation, this is our normal force equation, am I right? I have to apply the value of the P vector again. So let's write the equation one more time, and by that we can see whether the block is moving or not. So in second part, I am going to apply the magnitude of the P vector, which is equal to 10 Newton, in this equation. Which equation? The normal force, which is equal to 245 minus P vector magnitude. So when you substitute this value here, let's see what is the value of normal force. So Fn, normal force, which is equal to 245 minus 10 Newton, and here I got the answer as, it's not 245, it is 24.5, sorry. So 24.5 minus 10, which is 14.5 Newton. Clear? Because while I just write the equation, this point is not clearly visible. So actually here we have point. Clear? So after you substitute the value of P, you have to subtract 24.5 minus 10. We got the normal force as 14.5. Now what you have to do, again we have to find the maximum static frictional force. So maximum static frictional force for P vector, which is 10 Newton, what we got? Mu s multiplied by Fn. Again mu s value 0.40 multiplied by, and this time I have to substitute the Fn value here as 14.5. So what answer I got here? I got the answer here as 5.8 Newton. Now this is our maximum static frictional force for the value of P as 10 Newton. And what is our horizontal force, which is a 6 Newton. Now you have to compare this answer. So our applied force is greater than the maximum static frictional force. That means the object will be moving now. Why? Because our applied force is greater than the maximum static frictional force. So now what will happen? Your static frictional force is converted to kinetic friction. So we have to find the kinetic frictional force magnitude value. So as we already studied, the kinetic frictional force is given by the rule mu k multiplied by Fn. So our mu k value is 0.25 multiplied by our Fn force. So we have to go back for this. So our Fn value is 14.5. So I have to substitute that value here. So 14.5. Here I got the answer as 3.63. 3.63 Newton. So this is our kinetic friction force. So what you have to do, you have to give the answer here. Once your value of the horizontal force will be greater than the static, so you have to write the block is moving. The block is moving now. So that's the reason we find the kinetic friction value. Likewise, we have to do the same thing for our last value of the P vector magnitude, which is I think 12 Newton. I think so. Let's we just go back. Yes, 12 Newton. So let's we find the answer for the maximum static as well as the kinetic friction. So now what I'm going to do, I'm going to apply the P vector magnitude as 12 Newton, and for that I have to take the normal, the main equation, which is 24.5 Newton minus a P vector magnitude. So 24.5 minus a 12 value, we got the answer here as a 12.5 Newton. Now what you have to do, we have to find the maximum static friction value, which is Fs max value for this vertical force, which is mu s multiplied by Fn. Mu s value is 0.4 multiplied by Fn value is 12.5. After I multiply this number, I got the answer here as, let's see what's the answer, 0.4 multiplied by 12.5. I got the answer here as 5. What answer I got? I got the maximum static friction value as 5 Newton, but our applied horizontal force is 6 Newton. So when you have the values greater than the maximum static friction, for the value of P vector 12 Newton, the block is moving. Why? What's the reason? Because our F vector value, magnitude of the F vector value is greater than the maximum of static friction. Now again, you have to find the answer for the kinetic friction. Why? Because once the value of F vector magnitude is greater than static, your static friction is converted to kinetic friction. So we have to apply the rule for kinetic friction, which is mu k multiplied by Fn, right? So what is the mu k value? 0.25. And what is your Fn value? Fn value for this case is 12.5. So let's substitute the value. So 12.5. So when you multiply 0.25 multiply with 12.5, we got the answer as 3.13. 3.13 Newton. So this is the magnitude of the frictional force. So generally in this type of question, you have to find the maximum static friction value for every value of the P vector magnitude, and by that you have to compare that value with the horizontal applied force value. If your applied force value is greater than the maximum static friction, then the static friction value is converted to kinetic friction. Otherwise, you have to leave as it is. Clear? So here we have 3 different values of the P vector. So we applied 8 Newton. In this case, what happened in the first part? Our static frictional force is greater than the applied force. So that's the reason the block is not moving. So if the block is not moving, you no need to find the kinetic friction. But when you come to the second 2 cases, which is 10 Newton value as well as 12 Newton value, what is happening? We got the maximum static friction value is 5.8, but our applied force, horizontal force is 6 Newton. So the block is moving. In this case, you have to find the answer for the kinetic friction. So that's the reason for part B value, that is P is equal to 10 Newton and P is equal to 12 Newton, we have to find the value of the kinetic friction. Clear? That's it. This is the answer for this question. Thank you.